So we want to factor this particular polynomial. So when we look at it, the first thing that we want to check for is one of our factoring patterns. This one fits into the pattern that we talked about, the sum of two cubes or the difference of two cubes. Remember that both of these patterns essentially have almost the same factored form. The only difference that you see between the factored form for a sum of two cubes and a difference of two cubes is that this one starts with minus here and plus here for a difference of two cubes. This one starts with plus here and a minus here for a sum of two cubes. The reason I pointed out the difference of two cubes first is because obviously this one is subtraction. So it is a difference of two cubes. Now, how did I know it was a difference of two cubes? Well, first of all, like I said, it's subtraction. Second, it's two terms. And then they are both perfect cubes. The reason we call it a sum of two cubes or difference of two cubes is because those things that are here can be found by taking a base and raising it to the third power. A base and raising it to the third power. If you can find those two base numbers that are raised to the third power, those base numbers are what you use in the pattern. So this one is 2 cubed. Remember I told you I have some memorized? You may actually have to go through and use your calculator to find the perfect cubes. 125x cubed is also a perfect cube. It is 5x cubed because 5 cubed is 125 and x cubed is obviously x cubed. So 5x and 2 are my bases, my A and my B, that I use in the pattern over here. So make sure you understand that the 5x and the 2 are what we're using. We don't use the 125 and the 8. So we plug in the 5x and the 2 into each one of these spots for A and B. Again, the pattern's the same for both of them. So what I told you to do is not really think about A's and B's, but think about how you can just remember to subtract them, square the first one, multiply them together, square the second one. And then just switch up your signs if it's a sum of two cubes. So with a difference of two cubes, in the first parentheses, I'm going to subtract them. 5x minus 2. Then I'm going to square the first one. So if you square 5x, this one's a tricky one, you're going to get 25x squared because 5 times 5 and x times x. So you square the first one. Then I multiply them. So 5x times 2 is 10x. Then I square the second one. So I get plus 4. Again, using the pattern, you subtract them, you square the first one, you multiply them, and you square the second one. The only thing that would change, like I said, if you had a sum of two cubes, is your signs right here and right here. Everything else about the pattern is the same. If it is not a sum of two cubes or a difference of two cubes, this pattern will not work. If you had something like x squared plus 8, it's not going to work. That's not a cube. If you had x cubed minus 4, it's not going to work. That's not a cube. So it has to be a sum or difference of two perfect cubes for this pattern to work. Then it's just plugging the numbers in the correct spots. Remember also last time in class, we talked about solving equations by setting the factors equal to 0. Remember I told you that would be a headache with this guy right here especially because this one does not and it never will factor anymore. So that means if I was solving an equation with this guy right here, I would have to use something like my quadratic formula to find the answers to the equation. Remember the quadratic formulas, x equals negative b plus or minus square root of b squared minus 4ac all over 2a.